My name is Ilya Draitser, and I'd like to welcome you to this webinar. I will say hello, go off camera, and proceed to present our materials for today. And today we're talking about mobile malware, a favorite topic of mine, as a matter of fact. So this webinar is being recorded. We will share the recording with everyone at the conclusion. If you have any questions as we're going through anything or would like to discuss anything, please put it in the chat. And time permitting, of course, we'll look at it at the end of this half-hour segment. And I'll just jump right in and take it away. So these are the things that we'd like to talk about. So first of all, what's the difference between a vulnerable app versus an actually malicious app? Which dovetails into why signature-based tools really fail against modern malware. And I have some very specific examples of the picture as it is today compared to even a year ago. Then we'll show you how AI and machine learning helps to reveal these zero-day threats before they strike or before they affect you and me, mobile users, us all. And finally, how a cloud-based system for vetting can integrate into your enterprise MDM or UEM environment and provide continuous protection. And that's really the important part, right? How do we protect ourselves? So let's start with vulnerable apps and malicious apps. So I'll show you two profiles of an app. Here's one app A. It's a caller ID app. It has some interesting findings here. And here's app B. It's a file transfer app, and it has a little bit less findings. Now, the question is, which of these is vulnerable? Which of these is malicious? And what does that really mean? So app A, turns out it has a flaw, a vulnerability. It actually records information from text messages and writes it into the Android log. So this app has a vulnerability. It's not in there maliciously. Developers simply forgot to take out some debug logging, but it could be exploited, right? If someone gets your phone or if somebody gets another app which can steal these log messages, then they can grab your SMS traffic. App B, on the other hand, is very well coded. It only has a few issues. It has a very low threat score. And, other than allowing backups and, claiming to not have any data at rest encryption, other than that, it's actually very clean. However, turns out this app gained some notoriety in 2022 and 2024. It actually was in the Google Play Store. There was over 30,000 installations, and then it was removed because it turns out that it actually has malware embedded in it. So this app, it's not going to be exploited. It actually is malicious. And in fact, what's interesting here, of course, is that the app remains available for a while. Some of these apps are in there for a year or 2 years before it's discovered. And so when we look at what does this app look like from a malicious point of view, well, actually it's malware, it's a Trojan, and it sits there and it spies. And to conclude the picture, app A is vulnerable, right? It's not well coded. It has some weaknesses in the code, but it's not itself of malicious design. However, another app which is malicious could take advantage of these vulnerabilities and actually exploit it. But it would have to be a different app that does that. On the other hand, this app was actually designed to be malicious on its own. So this was part of the Mandrake chain of malware. It actually steals user credentials and executes additional payloads depending on the situation. And again, the important thing is it was in the Play Store for a year before it was discovered to be malicious. And that's really the story here. Why signature-based tools fail against modern malware threats. So the thing about signatures, the way signatures work, of course, is some researcher goes out and does some research and identifies ARFS, for example, is a malicious app. So they take that sample, they run it through a hashing program. It creates a fingerprint, which is really just a sequence of numbers. It's a hash, and it's unique for that application. And potentially you can hash things like libraries within the application in case one of those libraries is malicious. But essentially, you're creating a static fingerprint of that particular app that was observed to be malicious. And so they're unique to that element of malware, which is identified in the wild. Can't really be used to predict or discover malware that hasn't yet been fingerprinted. So in other words, it can only be used to identify the malware after it's been observed actually causing some harm, i.e. if the app is in the Play Store, enough that 30,000 downloads happen, that's potentially harm, right? So this is what it looks like. Here's the signature for AirFS. It's just this MD5 sum, and it's got some information in the database around, the downloads and when it was updated on Google Play, etc. And here's some other apps which happen to use the same family of malware. But as you can see, each one has a unique signature. It corresponds to a particular release. And this is how signature works, right? So this goes in the database, and then services, whether it's Google Play Protect, that actually, Google bought Reversing Labs, right? So now they have that database. And that database is shared with the likes of Trend and Sophos and pretty much any antivirus for mobile or any MTD solution out there. It's a database that we can all access, and it's great because if you install one of these apps and it's in the database, very quickly you can say, hey, that app is malicious. You don't need to do anything else. So what happens today that's different from a year or two ago? Well, last year this was reported where a new malicious campaign was observed, and the goal of the campaign was to create malware that steals people's SMS messages. And this campaign has actually been going on since February of 22, so it's actually more like 3 years. And during that 3 years, there have been observed 107,000 unique samples. So that's 107,000 unique signatures which were observed in the wild on people's devices over the course of this 2 or 3 years. So a Google spokesperson, of course, comes on and says, hey, don't worry, Google Play Protect is here to block these malicious apps. The problem is, of those 107,000 samples, 99,000 plus were unknown, right? So as they trickle in, somebody has to realize that, oh, wait, that's the same malware. It's just a different signature. So we update the database. So by the end of 3 years, the database has 100,000 signatures. And now we can find all these things. But it took 3 years. And here's why it's a problem today. And here's why the signature approach really doesn't work anymore. In 2022, right? Verizon put out, actually every year, Verizon puts out this really great report that essentially talks about mobile risk. And in 2022, if you look at some of these data points, the key mentions, the key outcomes, the key sort of things that this report is highlighting is mobile is important. People use it for work. More than half of us are using it. And, not too many people have been using it like in a secure way, right? That's essentially what it says is mobile is important. In 2023, it basically says the same thing. There's studies that estimate that cyber attacks on mobile are increasing. Mobile apps are getting connected into your cloud systems and backend, i.e. people use it for work. It's the same thing, right? In 2024, the message was pretty much the same. 50% of the devices have access to corporate information, 86% agree that flexibility and meeting people where they work is great. So again, the message is the same. Mobile devices and mobile apps are important. People are using it for work. All of a sudden this year, the report comes out and it's nothing but AI. It's just one giant, AI is here, and here's why this is bad. So literally the word AI appears maybe once, per year in the previous years in some way. And suddenly the entire 2 front pages of the report are, hey, AI is the big news. It's a rising risk on mobile. So it's literally like overnight, we all woke up in 2025 and realized that AI is a thing and we can use it to power attacks. And that's why the signature approach doesn't work, because 107,000 different samples took 3 years, and now it can happen overnight. And I saw this post on my LinkedIn feed just literally yesterday, and I had to add it into my slide deck because I couldn't have said it better myself. The issue is not that there's some new way of exploiting 0 days or other things. The issue is that you can do this overnight at a very cheap cost. And so this article or this person's post continues to talk about some details, but essentially it boils down to we can do overnight at a very low cost what we used to do in a year in actual programmers. And that's the real problem. And that's why the signature-based approach will never keep up, because we could spit out 100,000 copies of that malware with slightly different signatures in a matter of a few hours. And that's kind of the situation today. So, AI as a threat actor is kind of scary, but AI is a tool. The good guys can use it too. So, what can we do with AI? Well, we can use it to reveal these zero-day threats before they become a problem. We can identify the malware in a different way. And so, another approach, instead of using signatures, is to actually train an AI model to understand the behavior of the app, to understand what it's really doing. So the way we've done that is we've looked at taking a lot of malware samples. That you can get these samples from some databases where researchers sort of share malware samples for research purposes. But you can also get them from active investigations, meaning actual copies of malware which some police department has identified in a real scam, let's say, but they haven't been added to the database yet. And that's really the only way that you can train a model to be more predictive and not just look at sort of what's out there today. So the malware samples run through this engine to generate some data. But the other piece you need is you need some kind of ability to take an app out of the App Store. It doesn't have to be out of the App Store, but it usually is. And you need to be able to break that app down and understand what is the app doing, what's it actually consist of at the code level, what is it running. Now, manually, this effort takes usually weeks of a pen tester's effort to really understand what an app is doing. And if any of you have seen documentation on some of these postmortems on some of these malwares and how they discover them, it usually involves monitoring the app communication, potentially waiting a few days, because sometimes these things are on a timer, so they don't, react right away. They don't start doing anything malicious right away, but say 2 days later, they suddenly connect to a command and control server and start fetching instructions. And so, this is a very time consuming effort. But using AI, you can essentially take the behavior of the app, extract it, and start mapping what this app is doing. So the model is built on these proprietary engines that are actually able to take apart an app and understand its behavior. Where is it connecting to? What is it doing in memory? What is it doing with various processes? Is it activating certain bits of code in some, way that's based on a timer? Is it downloading additional payloads, et cetera? And it classifies that based on the existing malware that we've seen. And of course, we can train this continuously, as you typically do with AI. So the key thing is that it doesn't rely on waiting until some malware has caused harm in order to flag it. But it also doesn't rely on signatures. And that is why it can scale, given the offensive use of AI, where the attackers are using it to create these multiple variants. So when we look at that same situation of the 100,000 different samples, they're all samples of the same functionality. So when the analysis engine looks at 100,000 different samples, it basically sees the same thing. There's a bunch of behaviors that correspond to a Trojan. There's a bunch of behavior that corresponds to spyware. There's elements of malware, and then a sprinkling of other things, in the recipe, much like you would add salt. Well, in this case, the salt is great because we can figure out that this app is different from a normal app that's in the App Store that might also have behaviors like connecting to a server or downloading some functionality. But when you look at, there's well over 3 or 4 million apps in the App Store. When you look at a significant portion of those apps, you can very easily construct a graph of what those behaviors look like for a normal good app. And that's how this works. So let's talk a little bit about how malicious apps get on user devices, right? There's a few different ways. Phishing and SMS campaigns or messaging campaigns are very common. So you see a Facebook post from this is a real Facebook post. But this is driven by users essentially being told to go to some website and sign up and download something and sideload it. So, that's not the most obvious way. The most obvious way is to go to the App Store. And unfortunately, every year, Google and Apple actually announce how many apps they took down that year because they were found to be fraudulent, malicious, etc. Sorry. So the other way to get these apps, unfortunately, is from the App Store, and they do pop up in there, as you know. And the other thing is supply chain. So these apps could come pre-installed on a phone. It could come pre-installed on an Android-based device. Uh, Recently, Bleeping Computer had an article about some popular Android-based photo frames that actually download malware on boot and start doing bad things. And they have actually different strains of malware that they get. So supply chain is a real problem, but it's not limited to things like photo frames. First of all, lots of things run on Android, including those a lot of the payment terminals that you see, at Starbucks or at pretty much any retailer are actually based on Android, with a few of them based on Apple. And phones, right? Phones, especially Android phones, come preloaded with all sorts of things from the manufacturer, the chipset maker, say you've got a Verizon phone, it has a Verizon app. So, I mean, there's a lot of supply chain issues on mobile. And I think we actually did a webinar, if you're interested, on that just a month ago, which we have recordings of. The other thing is installing from unofficial app store sources, like unofficial app stores, or just searching for something. And zero-day exploits, of course, big deal. App collusion is something that I think is just not really talked about enough in our industry. But app collusion is when two different apps, that each of them by itself is harmless, but when you put the two together, they do bad things. So in the previous example, the SMS caller ID app that was leaking to the logs by itself is okay, right? It's not sending it to a command and control server. But I could write an app which pretends to be like a log cleaner or something. And if people download it and they have that SMS app installed, suddenly I can get my hands on those logs, right? So identifying who has which app installed on their phone and then crafting campaigns is a real thing. And I don't think we talk about it enough. So just to go through some of these examples, if you're distributing malware by the thousands, this is a real campaign that's been going on in Thailand for over 2 years. And because of the signatures thing, they just keep changing the makeup of it. But the campaign basically, sends a message that says, "Hey, you have a package coming. Go install this app to track it." And in the U.S., I've seen those same text messages, frankly, that talk about FedEx or UPS sending me a package. So it's a very common tactic in general. And when it involves mobile malware, this is a very standard thing that the phishing campaigns rely on, and yet it's malicious. Now, sometimes you can go to the app store and they have malicious apps, and as I said, they take them down once they get reported. But sometimes they stay in that store for 6 months or a year. This thing claims to be an antivirus cleaner, but actually it's got a malicious score of 70 out of 100 because it's actually a Trojan, and it was on the app on the Google store. And Apple, by the way, is not immune. I was looking at some samples from Apple, including one of just a simple helper app, which we analyzed 2 years ago. And I just checked the latest version. I didn't have a chance to put it in the screenshot, but it is actually very suspicious with a 68 out of 100 score. So these things are there. And again, unless somebody takes the time to do the research, or if you use AI to identify it, then that's the other way to stop it. And the third world scenario I wanted to bring up is unofficial stores or unofficial downloads, right? People are very good at creating these lookalike apps, which claim to be TikTok or claim to be Facebook or whatever, but in fact they're malware. And if somebody is foolish enough to grab one of those without checking, you get malware. So this is a real example that we tracked last year as well, of a TikTok lookalike that's actually just a standard thread of a Trojan and spyware. So these are some examples of how these things end up on our phones. Now, some of this applies to the enterprise as well, right? Because all of these apps can also be either lookalikes of legitimate apps or just helper apps. Hey, you use Power BI, and this is a helper app that lets you do that on mobile, or you use Salesforce, and this is a data entry app. And by the way, I'd like access to your calendar and contacts. So these things are relevant to the enterprise as well. And so with AI, the good news is even if you make 100,000 copies with different variants, AI can also identify that behavior and see that it's the same and generate and see the intention of the app to protect the users. And so that's the key here. So the last bit is probably the most important. How do you do this at scale? What if you have an enterprise with 5,000 employees? How do you protect all of them? And how do you make sure that they don't accidentally expose the company to risk? So there's two places where you can apply this AI-based protection. One is during development, right? As a developer of an app, check the third party code, check the libraries, basically validate that whatever the company sends to the app store as the finished version of the latest, banking app, for example, for our banking customers, make sure that nothing accidentally was added or maybe maliciously added in order to make the app malicious. As we talked about with supply chain, it happens. And validating that the version that's being sent up to the app store is in fact clean is very important. The other place, of course, is on the enterprise, protecting the mobile fleet. So a natural point to integrate this would be your mobile device management system or your UEM, because that is a system that literally controls the phones, but it doesn't provide security, right? So when we look at this diagram, on the left-hand side, you have the actual mobile device. And on the bottom right are all the different things that are already in most enterprises where there's some kind of system that rolls out the devices, that provisions them, that provides control, that determines which apps are allowed or not allowed to be installed. And so if you use one of those systems, it becomes very simple to add the bit at the top, the mobile threat intelligence, the application vetting, the security testing. This is something that Quokka provides, of course, but the point is that this ties into your existing infrastructure in a very important way. The other important bit here is, where does that AI algorithm run? Because if you try to run it on the device, then it's being reactive, right? You sit on the user's device, you consume their battery, you consume their CPU and memory. You're just constantly monitoring anything that the monitor can get its hands on and trying to identify these behaviors in real time. So at best, you can say, I just observed this app reaching out to a command and control server, but it already happened. But if you put that in the cloud, then now it's proactive. So those same apps, as soon as either they are loaded on the device, or what we're seeing with many of our customers is they have some kind of process where the user would request a certain app, they go through a vetting process, and then if they approve it, then it gets loaded on the device. That's a perfect place to do this kind of checking. And if you put that in the cloud instead of on the device, now it's proactive protection. And Gartner is talking about this too. When they talk about what are the different levels or layers of controls for mobile, you basically start with just data leakage protection, and you sort of add to that. So you put in some controls with MDM. You put in some additional protections with the EDR or MTD system, looking at phishing URLs or app behaviors. But if you do that in the cloud with the mobile app risk bucket, you get all of it. So the point is that in the cloud, we're actually able to implement all of these detections without having to do it on the user's devices. So it's both better from a privacy point of view for the users. You don't have to monitor all of their network traffic and what they do with the apps. And it's better from a proactive protection because it happens in the cloud. It happens before these apps are actually installed. So what we do is we look at all of these parameters that I talked about, the app collusion, the fleet level analysis, continuously monitoring apps as they go through updates. And we can answer these questions. Hey, a user wants to install this new Notepad app. Should we allow it? How do these apps behave when you combine them? How are the apps changing, right? We looked at Microsoft Outlook. They have a new version every couple of days. So is there any new risk or new library or new vulnerability being added in the latest update? This is what you can do in the cloud without bogging down user devices. It's easier to deploy. It's easier to control. So when we look at, some of the wins that we've seen from our customers, the obvious one is the app vetting is a very manual process if you do it the way most people do it today. You take the app, you give it to an analyst, they have to look at the app store listing, they have to do a little research on the company. Maybe you use another third-party service that does like a risk assessment of that company and their security posture. You try to do some testing with the app. You see, where is it connecting if you can. You do some traffic interceptions type stuff. It takes a week. And we've reduced that down to 1 to 2 hours. So when we look at something like, you have 5 app requests per week, that's a lot of analyst time that they could use for other tasks. And we've actually seen that in practice with some of our customer base. The other thing is, the whole reason we use mobile is because it's more convenient and it's always with us, but only if it ties into our corporate system so we can actually do work on it. And there's concerns about that because well, we just talked about why, right? There's all these problems. So by vetting the apps with this kind of security solution to make sure that they're not malicious and they're not vulnerable to be exploited, you can more confidently deploy these apps on users' devices, which enables people to do more work faster, and everybody's happy. And the last one, of course, is trying to reduce personal app usage. So recently, we were looking at an app that you use to take a picture of something and it turns it into a PDF for you. But it turns out that it also sends a copy of it to servers in China. And this is for a government customer, but of course it applies to any of us that have sensitive, IP, lawyer, legal type stuff, right? So, taking a picture and sending it to some third party is not ideal. But if my company doesn't provide that for me and I need a PDF, I might do that. And by doing that, I'm exposing the company to risk. And it's sort of the shadow IT concept, right? This risk is not really visible to the IT folks because it's happening on people's personal devices. So the more you can approve vetted apps that don't send those pictures to some third party that you don't like, the more likely people are to not have to use it on their own. And that's really the main takeaway is that if you plug this system in, uh, we call it Q Scout. If you plug Q Scout into your inventory, into your mobile fleet, you get the proactive protection. You don't have to deploy any agents. You get risks that are proactive as opposed to reactive, and you basically can do this at half the cost of modern solutions. So if any of that is of interest, or if there are any questions or thoughts, happy to take them. If you want more information, please take a look at the site or reach out to info@quaka.io, or even to me personally, ilya@quaka.io. Happy to take those. And since we do have a couple of minutes, let's just see if anything came in on the webinar chat. Which MDM systems do you support? Yeah, great question. So on the previous screen, we have a couple logos there. These are out of the box integrations, but the short answer is actually any MDM. So our team will integrate with pretty much any MDM as long as it has an API, which pretty much all of them do. So if you don't see your UEM or MDM on this list, please do reach out. We're happy to support additional MDMs. Is there a way to do this if you don't have an MDM? Yes. So there is a app vetting workflow where you could just go into the system and say, I noticed a lot of my users are happy with this app. What are my risks, right? So you don't need to have that integration into the MDM. If you are running a bring your own device fleet, then basically you get a web portal in your organization where either the users or the IT staff or security can go in and check for the security and maliciousness concerns of apps, sort of as users report them or as you become aware of any big ones. Obviously, you can't force people to uninstall because it's their own phones, but certainly you can give them a useful tool to look that up. And we've worked with private sector folks, government folks, and even a whole country that's launched this kind of portal. So again, if that's of interest, happy to discuss that as well. I think that's all the time we have for today. Thank you very much for everyone who made it. And for those of you watching the recording, if you have any questions or would like to chat with us, please get in touch. Quaka.io. Thanks, everyone. Have a great day.